We're going to take a look now at some test items from Chapter 5. Now remember, you're going to have a combined test, Chapter 4 and Chapter 5. I already have the Chapter 4 test posted, and it is rather comprehensive, much more than you will actually have on your computer generated test. It's a shorter test, and if you do well on the one I posted, you're going to do super well. So let's take a look at this and see what we can do as sort of a preparation for your test on Chapter 5. Okay, there we are. So the first item is to expand this base, which is a -2, and you're raising it to the third power, which is an odd number. So raising a negative to an odd power will give you a negative. So you've determined now the sign of your answer. Now you just have to go 2 to the third power is 8. Now number 2 is a little tricky because notice there's no parentheses here. So what is the base of this exponent? 4. And the answer is it's just the 2. So your answer then will always be negative, so you can put that there. And now you raise 2 to the fourth power, that will be 16. So your answer is -16. Now, just to give you some background on that, if that were a -2 in parentheses to the fourth, now we're raising something with a negative sign to the fourth power, which is even. This would be a +16. So notice the difference. That could be a little tricky. You have to watch the signs carefully and the rules that you're operating under. Okay, and the rule for a negative exponent is this is times 1. Everything is times 1. We're going to leave the 1 up in the numerator. And to get a positive exponent, we move the base and its exponent down to the denominator. As it crosses this division bar, the sign of the exponent changes and becomes positive. So then this simplified is 1/16. Okay, and here we only want positive exponents in our final answer, so no negative exponents. We're going to multiply the numbers. That'll give us an 8. And when we're multiplying variables with the same base and exponents, we just add the exponents. So 3 plus 5 is 8. A good technique would be to see what sign will your answer be. The sign of the answer here is going to be negative. Then we go 5 times 4 is 20. X, 5 plus 6 is 11. Now the rule here as we bring smaller numbers across the division bar, we want to keep it positive, the sign changes. So this is a to the third. Up here it becomes a -3, so we end up in the numerator. 6 minus 3 is 3, and this 2 comes up as a -2, b to the third. Now again, this calls for what technique you're using. This is all in a parenthesis and it's to the 0 power. And we said anything to the 0 power is 1. So that's something you just need to memorize. Reviewing a number of techniques here. Over here we have a fraction that is to the negative power. Well, we said whenever we have a fraction that's to the negative power, we can just take the reciprocal of this, which will be still a negative. Actually, it'll be a negative 3 over 1. That's the reciprocal. And that changes the sign of our exponent. It will make it now a positive 2. So in a sense here we don't need to write the 1, a negative 3 squared, which will be a positive 9. All right, now this one, you could do it a couple of ways. Let's try it. The first thing I would suggest. So within the parenthesis here, we can do some simplification. Okay? So I'm going to bring, now keep in mind we could flip this and that could become a positive 2 here. Well, again, we could do some simplification, but we'll do it the other way. I'm just going to do it as it's shown here. So x to the negative 2. Now, since we're raising a power to a power, we multiply exponents. So this is going to become x to the positive 4. Negative 2 times negative 2 is a positive 4. This just becomes y to the negative 2. Now, this is x to the negative 3 times negative 2. This will become x to the 6th. Y to the negative 10. Now we simplify, and we want to keep positive exponents. Well, we're not going to raise this up because it would make it a negative up here. So we'll bring that down, subtract it from 6. So in my denominator, I get x to the 2nd. That's a positive exponent. Here I'm going to bring this up. This is going to become a plus 10 up here. So this will give me then y to the 8th. And that should be our answer, and that's correct. Yep. Now, when we do scientific notation, we're going to put some number here between 1 and 10 and times it. This is not x. This is times it by some power of 10 to some exponent. Now, big numbers are going to have a positive exponent here. Small numbers will have a negative exponent. So this is going to be a small number. So our main job then is locate the decimal, which is right there, and see how many places as we move this to the left will make this a number between 1 and 10. Well, I'm going to move it over 1, 2, 3, 4, 5, 6 places. And by the way, that is my exponent then. I moved it over 6 places, and my number is 5.723. And that is in scientific notation. A number between 1 and 10 and depending on the number of places I moved it over, that is my exponent. And big numbers have a positive exponent for 10. Now, since this has a negative number, I'm going to write this number here, 7.94. But I have to move this decimal now. How many places? 6. Now, this will count for 1, so I have to add 5 zeros. 1, 2, 3, 4, 5. And that's what I'm going to do now. 1, 2, 3, 4, 5. I had to move it 6 altogether. So I put a 0 there to help lock that decimal point. And that is in standard form now, converting scientific notation. And because it had a negative exponent, I'm making it a small number. That is, I'm moving my decimal to the left. Okay. Now they want you to perform indicated operation and express the answer in scientific notation. Okay. Okay, so basically I took my calculator and I multiplied 2.4 times 3.8 and I got 9.12. And then I just added my exponents on the power of 10 and I got 10 to the 8th. This is scientific notation. Now for number 13, they're asking us to find the degree of the following polynomial. So what we do in a suggestion would be find the degree first of each term. Well, here, this one is 5. This one is 3. This one is 2. This one is 1. And this one is 0. Remember, there could be an x to the 0 power there. That is just 1. So, the degree of a polynomial, by definition, is the degree of its highest single term. And here, its highest single term degree is 5. So, the degree of that polynomial is 5. A suggestion would be find the degree of each term. And the degree of a term is the exponent or sum of exponents on the variable within a particular term. And these are all single variables, so rather easy to do. So here they're asking us to combine like terms. And we could do it horizontally. And since it's plus, by the way, you can just take away the parentheses. And what I'm suggesting, and even though you may not need it for this one since it's so easy, is to take your like terms, sort of identify them, and put them in vertical like term columns. And then there's this one, and this one, and then there's just that. No other like term to go with it. Now you just physically add these up. So this is going to be 6x squared. This is going to be minus 16x minus 9. And that's all they're asking you to do. Adding, combining like terms. Again, I'm lining up my like terms. So this will be 5x squared minus 15x minus 9. a good technique to improve accuracy. Now this was an addition. This one is subtraction. So again, a technique would be, write your top row here, 5x squared minus 3x minus 5. But now, since this is subtraction, when I take away the parenthesis, I have to change each of these signs to their opposite. So this will become a negative, this will become a positive, and this will become a negative. So when I line them up now, this is a negative 7x squared, a positive 4x, and a negative 4. The rule is, if you're subtracting, which is what this sign indicates you are doing, you take away the parentheses, change each of these signs, and then again line them up in like term columns, and this will become then a negative 2x squared. This is only going to be a plus x. We don't write the 1. And this is going to be a negative 9. We have subtracted these. Now for number 17, you're going to distribute through the distributive process this to each of the items in the parenthesis. So again, the first step might be, well, what will your signs be? Well, this one is going to be a negative something. The second term is going to be negative times negative. That's going to be a positive something. And this will be a negative times a positive. That will be a negative something. And now you don't have to worry about the signs anymore. So this is going to be 6x to the 7th power. This is going to be 4x to the 5th power. And this is going to be 8x to the 3rd. And you can check your work. So that was negative, positive, negative, 6, that's good. 4 to the 5th, that's good. 8x to the 3rd, okay, that's good too. Now, here there's the traditional way of doing it or the FOIL. And what we'll do is we'll do the FOIL. You'll be using the FOIL a lot in Chapter 6 in your next course. So this is going to be 6x squared. Now my outers will be a positive 9x. My inners a negative 10x. And my last a negative 15. And we see we have like terms in the middle, so we combine those like terms. 6x squared minus x minus 15. For number 9, hopefully you have mastered this special product multiplication in which you are squaring a binomial. We square the first term. We multiply these two terms together. That's going to give us a 6x, but we have to double it. So this eventually will be a 12x. So the rule is square the first term, multiply these two terms together, then double it, and then you square the last term. Now I wrote this here as a little reminder of that special way to square a binomial, and our answer then will be 9x squared plus 12x plus 4. And do you remember what we call these? This is a perfect square trinomial that when we want to factor that in chapter 6, it will become this. Okay, and here's another special product where we are multiplying conjugates. Now, conjugates are sets of terms that are the same, but one's the sum and the other's the difference. Now, when we multiply conjugates, we get what is called the difference of perfect squares, because the inner and outer terms cancel out. So here we're going to get 4x squared minus 25. And in number 21, which is a division problem, the method we said that you should use for these is to put each of the terms in the numerator over your common denominator. And then just simplify them. So this is going to become x to the third. As we simplify this, this is going to become negative 4x. As we simplify this, 4 goes into 16, 4 times, it's going to be negative. 2 from 3, leave me with a 1 that we don't write. And here, all we're left with is a negative 2, because the x squares cancel out, and we get that. Now, if there is a variable in the denominator that's larger than the one in the numerator, you may end up with a variable in the denominator. So keep that in mind. Okay, we'll do a long division now. Okay, I've set it up here, and I check it to be sure I have copied it correctly. Yes. Now, the first thing you want to do is to see how many times this term goes into this term. This is often a difficult thing for some students, but a suggestion would be take this term and just divide it by that term. And 2 will go into 8 4 times. And then that's going to be x to the second. So if I just simplified that, I get this. So now when I multiply this times this, I get that. So that's 8x to the third. That's what you want to do. But now the key is you have to take this next term, a negative 3, and multiply by that. So that's going to be a negative 12x squared. Now, another thing you may have run into is that you need to have it set up correctly with descending powers. If they're missing a power, like if x was not there, then you'd have to put 0x as a space holder here so that you could work it sequentially. So now I put my line. Now the next step is crucial, because what are you going to do here? We're going to subtract. Well, how do we indicate subtraction in algebra? We change the signs and then we add. So these cancel out. You don't have to write anything there. And here we have a negative 4x squared. And we bring down our next term. Now you can put it over here, negative 4x squared divided by 2x. Well, that's going to be a negative 2x. Just dividing that. Okay, so now we go 2x times a negative 2x is a negative 4x squared. A negative 3 times this is a positive 6x. Put our line, and now what do we do? Well, we have to change our signs. So this is going to become a positive, and this is going to become a negative. So these cancel out, and this becomes 6x, and you bring down your 4. And then again, 3x will go into there, 2x will go into there 3 times. Thinking ahead here. So 2x times 3 is 6x. A negative 3 times a positive 3 is a negative 9. So what do? We change our signs and add. This cancels out. I end up with a positive 5 remainder. Now, how do we write our answer here? So this is number 22. Let's put it right here. 4x squared minus 2x plus 3, and you can put a plus there. You're going to put your remainder on the top, and you put your divisor on the bottom. And there's your answer. Now, we don't do synthetic division, and we didn't do the remainder theorem. So that will be our review of Chapter 5. Remember, it's a combination of 4 and 5, and it will be, again, not too many problems, but hopefully this review is helpful, and good luck on your test.